time marches on. You can see the clock ticking down. So this is our very final session of talks this morning. And so we're going to start with Emmylou Haffner, who is going to talk to us about Veblen's 1901 notebook on the foundations of geometry as an axiomatic laboratory. So actually it's rather fitting, Emmylou, you're going to be talking to us about Veblen, because we kind of started this whole program back in January, I can't believe it, 4 months ago, with people working on Veblen. So it's really nice to have somebody else to kind of bring that back together again. So take it away.
Thank you, June, and thank you to the organizer for the invitation. So I'm going to start with a throwback to the opening workshop in January, where Niccolò Guicciardini talked about Whiteside's work as the editor of Newton's collected works, and he mentioned Whiteside's intention of publishing what he deemed to be significant in Newton's manuscript, citing this footnote in which Whiteside said that his definition of Newton's significant mathematical work does not comprise the entirety of his calculating sheets or of his annotation of the work of others, and he also dismissed the crude and uninteresting algebraic passages in some notebooks. Niccolò himself, and in a later talk also Scott Mandelbrot, suggested that neglecting this crude computation and the non-Newtonian hands that should be mentioned somewhere in the quote led to missing some important aspects of mathematical practices, including the fact that manuscripts were a communication, sharing, distribution, and collaboration tool. And Scott underlined that our relationship to archive has changed since Whiteside's edition. It was also very visible in the talk on Leibniz manuscript given by David Rabouin just after Scott's talk. And so broadly speaking, my talk today will go further into the idea that our relationship to archives has changed, and I want to talk about all this insignificant part of the archives, and in particular of drafts. And so by drafts, I mean private manuscript, working manuscript, bearing the traces of preliminary research with or without intention of publication. They can be in notebooks or in journals, as we saw in John's talk, but not necessarily, and for me, it's not very important. But they are often left aside as insignificant, hard to navigate, too incomplete, too preliminary. And in my own work on Dedekind's Narlas, I've seen similar statement by Winfried Charlao, who did the catalog for the Dedekind's Narlas, and at some point wrote about a bunch of manuscripts that they were of little historical interest. And you could say that I disagree with this judgment, as I have written about 150 pages on this manuscript, most of them in the Duality book outside. And so this manuscript, Dedekind is not the point, but it's a good intro into the question of drafts. So they deal with Dedekind's theory of modules and how part of it was developed into what Dedekind called dual gruppen, which is basically a lattice. And I just quickly want to mention some of what studying this uninteresting manuscript revealed, because this draft unveiled elements of Dedekind's mathematical practice that had been effectively hidden while when he wrote the version of his work that he considered suited for communication to the scientific community. So in particular, the draft show that Dedekind used a very stepwise approach to the generalization of his results, manipulating simple cases, testing properties on progressively more general cases, rather than approaching these questions in the abstract structural axiomatic approach that is often attributed to him. And related to that is the important role played by computations in exploring the properties of modules and later dual-gruppen, which allowed him to observe the properties and laws verified by the operations between modules and later more general objects, let's say, which of course led to proof, but it's very striking for Dedekind, who really did not like computation and openly argued against computation. And finally, the drafts also show a prominent role played by the shaping of written tools like notations or tables to support the computation in a way that is not only efficient, but also makes visible what we could call structural properties of dual-gruppen. And this is also quite striking because Dedekind famously advocated for mathematics relying on concept and internal characteristic rather than on representations, and is so careful with his notation and experimental with his notation that it goes a little against his public principle, let's say. So if you know Carl Siegel and later Harold Edwards' arguments against an image of Riemann as a purely conceptual mathematician, this can feel familiar. It has also been said of Galois. And so the idea here is very well summed up in the quotation from Edwards' paper. Maybe Riemann was primarily interested in grand general abstract concept, but he did not venture into these higher realms without doing a lot of serious computation to lay the groundwork for his work. And it's the same with Dedekind, except not the same computation because not the same mathematics. There's a lot of other examples of works showing how drafts tell us more than what is published, from Descartes' work on Blaise Pascal manuscripts to current works done on Leibniz, of course, on Alphen by Nicolas and David Vasek, or Einstein manuscript by Tilman Sauer. And this is in line with fairly provocative statement by Nobel Prize Peter Medawar. So he was a Nobel Prize in medicine, who wrote he gave a talk in '63 entitled "Is a Scientific Paper a Fraud?" And the idea is that the scientific practice as it is published and publicized is not representative of the everyday research practice, even though the latter is what constitutes the heart of science. And the contrast between what is shown and what is done in science and in mathematics in particular was also highlighted in this paper by Ruben Hirsch, in which he took up an idea by sociologist Erving Goffman, namely that there is a back and a front of mathematics, so areas in which the public is allowed and areas in which it is not. And so drafts, of course, show the back of mathematics, the unfinished and often not very formal side. So, in other words, the drafts are mathematicians' tool for their research, some of which, they are their laboratories, a place where we can witness the steps of the research, some of which were erased from the publication, like Dedekind's computation. And as such, they give us an internal view of mathematical practice, which can be sometimes very different from the idealized image of a very normed, somewhat rigid text, which we have become used to, especially in contemporary mathematics. And as such, I think that they allow us to better understand the shaping of mathematical ideas, results, or theories. And not only do they provide us with additional elements on their author mathematics, which I think is important for the history of mathematics, but they also make us reconsider some of what we thought we knew by studying only published work. And of course, the composition of a text that can be read by the mathematical community is a very standardized practice, which does not always reflect the genesis of the concept, which is answering a number of sociological and disciplinary norms, which we all know since we all write papers. So, at the same time, drafts are a very specific type of manuscript. First, of course, they were not meant to be read by anybody else but the author, and they can be difficult to interpret for this reason. They can be a little obscure, and they also require us to accept a certain fluidity in the text, to accept that we work with temporary states of text and temporary states of knowledge to an extent, which sometimes can coexist, of course, and which may or may not be part of a larger process toward a final state of text. And so in this also they require a certain caution in the interpretation. And to handle this, it can be useful to consider methods from literary studies, which have been studying writer's draft for a long time, and in particular something called critique genetics, or genetic criticism, which is something that was invented in the late 70s by Louis A., who will turn 100 next year. He is the founder of my lab. And the idea is to look at the temporal dimension of writing and to try to understand the creative process through looking at the author draft. So you use the material witnesses that are the draft to understand the writing process and the creative process. So it's a philological work on archive also, but of course, but also a work of interpretation, of reconstruction of the author steps, of the stages of development of the text. And if you have a mathematical text, you can also look at the conceptual, the stages of the conceptual development. Of course, it can be a little tricky for us that with a genetic approach, you always read the manuscript with a very teleological approach, the endpoint being published results or paper or book or poem or whatever. It's not a problem for genetic criticism per se, but for us as historians of mathematics who maybe want to understand the mathematical practices in draft without over-interpreting documents with a retrospective light, we should be a little careful. But this is our job, and for this, we can rely on reflections developed in the history of science, history of text approach, especially the idea that text and the concept they contained are elaborated together, as presented in this quote by Karin Shemla, which I really like. And I'm not going to read everything, but the important part is the first, the second paragraph. We reject the presupposition that one's concepts, results, or theories have been obtained by other ways in an immaterial space. They are transcribed in a textual form that remains indifferent to them. We assume that the text elaborated in the course of the practice of science belong as such to the outcome of the scientific work, along with the concept, result, or theories in intimate connection with which they are shared. So since we are looking ahead, I just want to mention some collective endeavors that are currently doing that. It's a bit advertising because I am in some extent involved in all of these things, but sorry for that. So you've heard David. I think some of you probably heard Christophe Ekes as well. We will have, well, it's all in French, but we will have a special issue of the official genetic criticism review that will appear this month, if I'm not mistaken. And the last one is it's in a very early stage, but we had a meeting at the Tray in March, and there were 15 of us, and we are working hopefully on a book that will be the first official genetic criticism for mathematics book. Okay, so now to Veblen. So I will talk about just one notebook of Veblen's. You have the reference on the first line. It's notes from a seminar led by Moore from autumn 1901 through summer 1902 on the foundations of geometry. It's also the place where Veblen first began working on what would become his PhD dissertation. You have the reference on the slide as well. And Moore himself credited the seminar for informing his own 1902 publication on the foundation of geometry. So the notebook documents the teaching at Chicago of very contemporary approaches to the foundation of geometry. And most of the pages appear to be a mix between lecture and reading notes, the lecture consisting in fact in reading the sources. And we see in the notebook early forms of Moore's contribution to the subject, as well as Veblen's personal reflections as the seminar progressed. So Veblen's notes testify to a very fruitful collaborative and critical engagement with sources on axiomatic, and as Michael Scanlan observed in a 91 paper, the seminar was a particularly formative event in the constitution of a school of what we call American postulate theorists, in which Moore and Veblen occupied a central position. So in paper that we will submit to the bulletin of the AMS with Nicola and Gemma, we are looking at the notebook in a more in the context of teaching and collaborative practices. So part of the talk comes from the work we've done together, and part of it is my own. So if I say anything stupid, it's my fault. Of course, don't. So the notebook is 124 pages, but a lot of them are left blank. And it mostly documents a comparison between different published axiomatic systems for the foundation of geometry. And so this is the very beginning, a typical page. It's written in black ink, but sometimes we have additions in pencil, which are usually Veblen's own personal reflections. And sometimes, more rarely, we have some little sheets of paper pasted in the notebook. So Veblen's notes from Moore's lecture give us a testimony for both mathematicians' work, since they are by Veblen's hand, but they remain lecture notes, so the Moore's input cannot be dismissed. And for this part, you can refer to the paper with Gemma and Nicola. So in the paper, we talk a lot about the reappropriation of contemporary sources as an aspect of the work done in Moore's seminar. And in the notebook, it manifests itself not only by the many reading notes, but also by the fact that the construction of a new axiomatic system by Veblen himself is done largely through comparisons of this system. So the most significant sources are Hilbert and Peano, and they are the only one I will talk about for, brevity's sake. And I will start with an excerpt from Veblen's treatment of Hilbert's axioms, and I will just look at a small aspect of the axioms of order. So this is what the reading/lecture notes look like. On the right-hand side, you have the notes, and the left-hand side is left blank for, additions or whatever. They work on Hilbert's original text because the English translation was published the year after the seminar, so it's their own translation. They are usually very faithful and in this notebook fairly accurate. The only change in this page is the introduction of the notion of collinearity, which is not in Hilbert. But we have a systematic translation of all the axioms that are in Hilbert's foundation of geometry. But if you look here and there, Veblen proposes to introduce a notation to say that if C is between A and B, then you will write ACB or BCA. Not very surprising, and you can do the same with 4 points. You can do that with as many points as you want. So it's not a very innovative or impressive notation, but it will become very useful because it will be used in a more interesting notation, which is a sort of a mix between a diagram and a notation. So the idea is that you read this like that. If A, B, and C are in that order, and A, C, and D are in that order, then B, C, and D are in that order. So this is the notation that he introduced in the previous page and my previous slide. You see here what's left blank for the B. And the therefore and the line were used in logic since the 19th century. So if you have done a little mathematics, you can understand this fairly easily. And it's quite a striking notation. We haven't been able to find it anywhere in either published sources or manuscript. So it seems to be completely original to Veblen, but he did not publish this notation. And it is first introduced in a 2-page proof entitled Simpler Form for 2-4. So 2-4 that I did not read is this one, and if 4-point ABCD of a line can always be so arranged that B lies between A and C, B lies between A and D, C between A and D, and C between B and D. This is in fact a first step toward proving that Hilbert's 2-4 is redundant and that you can prove it with other axioms. So Veblen starts by giving an alternative axiom, which he calls 2-4 prime, which is the one I showed you when I showed the notation. And the idea is just that this is the simpler form, and he proved that you can deduce 2-4 from this one, and so this is the one that you should use according to him. It's not, I mean, it's open to interpretation that this is actually simpler, but that's not my point today. So for this, he gives 3 theorems. So this is the first one, alpha, and you see there's almost no words. It's all done with this new diagrammatic notation. It's a proof by absurdum. So here you have if A, B, and C, and A, C, and D, then A, B, and D. And then you just assume something that negates the conclusion, and it's fairly easy to prove. I will not read it. But you see, the notation is very intuitive, very visual. For the next theorem, it's a little bit more complicated because you have a lot of possibilities. But once again, with the notation, Veblen can sort of explore or see all the possibilities at once. So he uses these curly brackets, which is fairly not unoriginal, and this is something that he uses in his notebook all the time in discursive part and in non-discursive part, and which we found with Gemma and Nicolas can help understand some of what Moore was doing with his notation in the publication, but for this you should read our paper. Anyway, so the cases are presented one after the other here in the proof in columns, and you can go through it relatively quickly and efficiently. And if you look carefully here, you see that he is proving one of them using the next theorem, theorem gamma. So the chronology of writing in this part is a little complex. We have signs of erasure here, which are very difficult to interpret because we cannot read anything, and we can see here that probably he wrote the theorem, the third theorem, before finishing his proof, and the most likely interpretation of this correction is that he started with theorem gamma, changed his mind, but then he still needed theorem gamma. And okay, and here it's broken, but only because there is not enough room. And this is the last step. Still the same strategy, a proof by absurdum using the notation. You get the idea. And from what I just said, you can easily compare the effort that theorems like that, like if A, B, and A, C, and D, and A, B, and C, then all these possibilities and so on. It's very cumbersome to do with words, but Veblen's notation is extremely efficient. It's space-saving, it's time-saving, and it has very strong visual component. It reproduces visually the alignment of points and the inference process. So it's not just an economic notation, it's also a tool to synthesize and support the reasoning. Since even in the more complex cases, like this one here, you can explore all the cases in one look, more or less, maybe 1.5. But it's not sort of a Leibnizian blind guide for blind thought theory, because also in this more complex case, you cannot just read, you have to think about it a little bit and to go through the cases. So it's a support to visualize the relative position of the points, but not something that you would use blindly and just automatically do the deduction. And it also shows, of course, Veblen's desire to be concise in a fairly repetitive work. And the notation is used in a number of other proofs because the order of points is central in Veblen's foundation of geometry. So this is just, as I said, a step toward eliminating 2-4, which is done in Moore's paper, where he credits Veblen for finding it. And in his published dissertation, Veblen presented Hilbert's axiom as a theorem. And he reminds the reader that this is Hilbert's 2-4, and he credits Moore for proof of the redundancy of this axiom in Hilbert's system. So and this is the section that is the closest to Moore's works, so to his advisor works on the foundation of geometry. So if you only compare the published text of Moore and Veblen, you could read that as Veblen being derivative of Moore's, and conclude that there is sort of a one-way relationship between professor and student, in which Moore proves the theorem and Veblen establishes nearly the same results, but with the hints in the footnote, and more importantly with the pages in the notebook, you see that there was a more interactive progression during the seminar. So a very striking example of axiomatic research in progress from small reformulation, like the introduction of the notion of collinearity, to substantial revision. I will not go further into the reading of Hilbert's Foundation of Geometry. I just want to mention that they do not stop at the axiom. They look at a lot more stuff in the book, and one of the pages I showed earlier was in fact on Desargues' theorem. Okay, I want to look at what he did with Peano's axioms. So this is the first page of note on Peano's postulates. Same idea, direct translation from Peano. So it's an English translation of Peano's symbolism. There is one page with a symbolism, but everything else is in English. So the same is done for all axioms in Peano's paper: linear, plane, solid, and motion. But only the linear axioms are subjected to an in-depth analysis and a modification, which is on this page, very explicit. And I have done comparison axiom by axiom. So the first two axioms are about points. So one can mark a point in Peano, becomes there exists a point in Veblen's version of Peano. And the second one, given a point A, one can mark a new point X different from A, and here you have given a point A, there exists another point B, and the third one is also on point. Between two coincident points, there lies no third other point, and there is no point X different from A, such that A, X, A, so the 3 points are aligned. X is between A and A. So already you can see some terminological changes that highlight conceptual differences between Peano's approach and Veblen's approach. And so in the change between one marks and there exists suggests that rather than geometry as something related to figures that can be drawn, Veblen adopts a more abstract, maybe more Hilbertian approach. And here, Peano's axiomatic is blended into a more Hilbertian conceptual framework. Without it, you will see being just a sort of translation of Peano into Hilbert. That would be too easy. And the use of there exists can also be probably related to Scanlan observation that Veblen adopts Hilbert's conception of existence of mathematical objects as amounting to syntactic consistency of a theory, and not the view of the Peano school that the consistency of the theory amounts to the existence of appropriate mathematical objects. Moving on. Axiom 4 and 7 in Peano are fused together to give this axiom. So between two distinct points, there are points. And if A and B are two distinct points, then there exists point of the prolongation A prime B. So you have a segment and you can do a half line. And this is reformulated as if A and B are points, there exist 3 points such that you can order them in that way. Peano's fifth axiom is reformulated into this is just Hilbert 2-1 axiom. So if C lies between B and A, it lies between A and B. And then you can say if ABC, then CBA. And as a sixth axiom, for Peano, you have A does not lie between A and B. The end of the segment is not its interior. I think I'm missing a word. And Veblen replaces it by if ABC, then not CAB and not BCA. And he writes in the margin C Hilbert 2-3, and this is Hilbert 2-3. Of 3 points on the line, there is one and only one lying between the other two. And Veblen has an axiom 7, which is the 2-4 prime that we saw just a few minutes ago. And he refers to his page 33. This is his annotation, which is the page I showed you with a simpler form of 2-4. And that's all Veblen needs, but not all Peano does. And there is a definition of prolongation that Veblen does not need, and 4 more axioms that I will not read, but Veblen proves that they can be used as theorem. So P8 is in fact Veblen's theorem gamma, P9 is his theorem beta, P11 is his theorem gamma. Here you have a proof of P10, sorry, and P6 is equivalent to a theorem, which is if A, B, C and B different from C, then A different from B. And here you see that he's referring to a 6, so in all likelihood that should be this 6 here. But I just want to show you something a little weird. I have no good explanation, but this is the fun in draft. So this is in the translation, on the page with the translation. Veblen already wrote P6 is redundant, and he gives a little proof. If you look at the page with the modification of the axioms, in fact, Veblen's 6 is stricken out with pencil, and he wrote a theorem. So I changed the contrast a little bit so that it's readable. But of course, it cannot be this one that is proved as a theorem, because then we do not have a 6 to prove the theorem with. And on the left-hand page, we have some pencil annotation. It's not very pretty, but it's kind of readable, with another 6, well, actually 2 versions of the 6, here and there, which say basically if A, B, C, and at least one of, there is a mistake here because 2 are similar, but you can see which one you want, then at least one of this and one of that. So maybe this is a new 6 that he wants to use. So the simplest hypothesis is that Veblen came back later, corrected only this, and wrote some idea for replacement of 6, and did not bother to correct the proof of P6. But this seems to just be a more exhaustive version of 2-4 prime, so you would need to do more modification in his axiom system. If you wanted to take this as an axiom, you would need to get rid of 2-4 prime. Maybe these pencil notes are here by coincidence. it's not very likely, but it's possible. This is all very speculative. So, as I said, there is no notion of prolongation, but there is a definition of line. So this is pianos given 2 points A and B. The line AB is the aggregate of the points, the segment, and the prolongations. And the modification of piano's definition is the line AB consists of all x such that you have this order. He reformulates again in this framework of order and point and order, and just give you an idea. This is Hilbert's line, 2 distinct points in AB determine the line. We say AB is the line. So Veblen only needs 7 axioms and not 11 like Piano did, and less definition. And we notice that Veblen pays attention to which axiom can be deduced from other axioms. So he's paying attention very early on to the independence of axiom, which will become something very strong in his dissertation and in the postulate theorist school in general. Okay, I will move through this last part a little quickly. We have the very first version of Veblen's projective axioms that will end up in his dissertation. So this is what it looks like. I have a transcription with a comparison to the existing axiom. So the first is there are at least 2 points, so it's equivalent to piano 1 and 2 fused together. And you have the things between chevrons are the pencil annotation in this page. Then you have A and B are 2 distinct points. There exists a point x such that x is between A and B with some addition. This is equivalent to Hilbert 2. Then third axiom, whatever A, B, and C are, or whatever points A, B, and C stand for, if you have A, B, C, then you have C, B, A. This is equivalent to piano 5 and Hilbert 2. Then you have whatever A, B, and C stand for. C is not between A and B, or another way to say it, A, C, B does not hold true. This is Hilbert 2, 3. Then you have this is the one I showed you in the pencil annotation. A, B, and C are points, distinct points. Then if you have A, B, C and any one of this order, then this is a weird correction. You have at least one of this order. So this is a sort of more general 2, 4 prime, if I'm not mistaken. The 6th axiom is equivalent to if A is a line, there is points, a point that does not belong to a line. It's piano 12, so it's not in the linear axiom, it's in the space axiom in piano. And the last, is it the last one? It's not the last one. The 7th one is, so I put the little drawing that Veblen does so that you have an idea, because I don't really want to read the points, but it's equivalent to Moore's axiom 4, which is the triangle transversal axiom. It replaces the 2 triangle axioms introduced by Piano as fundamental for the theory of the plane, which replaced Pache's plane order axiom retained by Hilbert as 2, 5. So this is Moore's explanation. So you understand what's happening with the little triangle. Then the 8th axiom is there exists a point not in plane, so this is piano 15 in the solid geometry part. And 9 is there is but one space, which I have not found anywhere yet. There is on the next page definition of a segment, prolongation, collinearity, triangle, line, and plane. I'm gonna skip that. And on the left-hand page, there is, you see here, a proposition to rearrange the axioms. I also have pretty slides, but I'm going to skip them. Here is the idea. He gets rid of axiom 2, apparently, for some reason. He adds a short definition of betweenness for segment. Between what was axiom 4 and 5, he adds notational details and the definition of a segment. He seems to be moving axiom 6 to be together with axiom 8 to do something that seems a little extreme, which is having together the fact that there are points that are not collinear and there are points outside of a plane. And he adds a definition of line and definition of plane. So this is a transcription. So here is a slide of comparison between the third version and the published version, where you see what things become. I think the next slide is easier to understand, but I just want to mention that in the published version, prolongation and details of notation are suppressed, and he adds axiom 4, which is if points ABC are in the order ABC, then A is distinct from C. He adds definition of the interior of triangle and 2 definitions and 3 axioms for space, which you can see here. So you have a comparison of the structure. The color are just to give you an idea of what is going where without having to think too much about it. They do not mean anything. But you see there are some significant changes, but the basic idea is already here in the 1901 version. And the conceptual framework, which is point and the relation of order, does not change at all between the notebook and the published version. Okay, and then this is my conclusion slide. So the notebook, as a completely unfiltered material, illuminates better the research and decision process than merely comparing published papers. It gives us additional clues to understand how the axiomatic systems were built, how the axioms were chosen. It shows the stepwise experimentation on axioms, as well as, let's say, everything around it, like work on notation. And it also shows a complex web of reappropriation of contemporary sources to elaborate a new conceptual framework and a new system of axioms for the foundation of geometry. We have some elements from Peano, some from Hilbert, some from Moore. And it's all heavily influenced by Hilbert's overall. And we see that the insistence on independence of axiom emerges in the notebooks as well. And that will be all.
Thank you very much, Emmylou, for this very rich talk and for keeping so brilliantly to time without any prompts whatsoever. So we do have time for questions. Bridget?
Apologies for sitting so close. I was wondering if you could say more about the writing of the notebook. So it was the pen written during a lecture given by Moore, and then he went back to the pencil, or is it like a neat copy that he did later? Do you have any idea?
No, probably the pen was written during the lecture, and I mean, we don't have any explicit statement about it, but it's more likely that the pencil was coming back later, yeah. But we think that the pen was written during the lecture.
Maybe I might ask a question. I mean, so is this a unique example from Veblen, or are there other notebooks with which you can compare it for whether he's doing using his notebooks in a similar or a different way?
So we have a number of notebooks in Chicago, but Nicola knows more about the other notebook actually because he went to Chicago and I didn't. But I don't remember if we have notebooks by Veblen.
No,
We do?
There's also one in the Library of Congress, another one from Veblen. It's from lectures by Mashko.
Ah, yes. Yes, I don't have the copy of this one.
And do you think that he would maybe have had other ones that he didn't keep, or he kept these ones because obviously this one was sort of fundamental for his book and things that.
He kept more. He kept at least two, and the thing is there are different statuses because some of the notebooks that are in Chicago were clearly kept for internal use within the departments as like records of lectures that other students later on should be able to consult, and some were clearly more advanced notebooks building on something kind of like a pre-PhD work. But so some of the notebooks are of a more elementary level, and some of them are setting notations and definitions and terminology for other students, or some of them are how should we translate and read this German book into English? Because some of those texts are really sort of passing knowledge of modern German mathematics into the US for the first time, so they have to settle down on notations, translations, reference texts. So there's a range of uses of those notebooks.
And are the ones that are circulated within are there annotations by other people within them, or?
Yeah. There's a group of students. There's at least a dozen of students who have notebooks in those archives. Of various natures over the period of since the foundation in 1891 up until 1910, roughly, we have something like 40, 50 notebooks.
Really? Yeah. Okay. Yeah. Thank you. Thanks.
You wrote everything in the bulletin about it.
Yeah.
In the bulletin paper.
Yeah.
I just have a question of a much more general order. So at the beginning of your talk, you quoted, I think it was Karim Kemla,
Yeah,
exactly, on the fact that we should have a genetic approach to mathematical articles. But this sounds very kind of like it's hermeneutical. This is, because it looks like you're basically, this is a certain hermeneutical stance on articles. That is, you want to understand them in their context, and so I was just wondering whether that there's implicitly here a lot more thought about the methodology that's employed. I mean, have you ever thought of using hermeneutical methods?
So first I want to say this is not about genetic methods. I don't think Karine would be very happy if we said that she's doing genetic things. But I have not think about hermeneutical method personally. I don't want to answer in place of Karine, especially since I am being filmed, so I'm not going to take any risk.
Okay. Michael, I think you had a question.
Thanks. I wanted to bring us back to that first line of your concluding slide, where you talk about the notebooks as a kind of unfiltered, sort of more authentic view of the research process. And I've seen claims like that in other of your work from the Bouillon project and elsewhere, a sense of notebooks as providing sort of less mediated, more immediate, authentic views of mathematics. And I wonder if that sells short, actually, the insight that you're developing from this project and your related projects, which is not to say that there's a kind of true process of mathematics in the notebooks and a kind of fake process in the articles, but rather what you're giving us here is a better way of understanding a kind of ecosystem of different forms and kinds and genres of writing, and whether it would be more effective as a conclusion to see the notebooks as itself constituting a genre with its own constraints and norms and expectations and limitations and deceptions that has a kind of complementary role to articles and books, and indeed lectures and seminars and other settings of mathematical materialization. So I guess to turn that into a question, I think, would it be possible to turn the kind of analysis you're doing instead away from a perspective that presumes the transparency or unlimitedness of Bouillon of different form, and instead, by focusing on the constraints, perhaps give us a more comprehensive view of the role of writing in mathematical research?
Yes, of course. Yeah. I mean, no, that's one of the aims that we are pursuing with the Brouillon project and the Bourbaki project and the genetic criticism as well. But it's difficult to look at the draft without thinking of what was published, because you need some sort of anchor, or you are just very, very lost. And
yeah, no, I mean, I think just
but in a long-term view, yeah, that would be the dream.
Yeah, I mean, I think that's maybe a frustration I have when reading your analysis of these kinds of materials, because it's such a brilliant analysis of the mechanics of writing and the way it shapes thinking, but it's framed by this kind of language of it being unfiltered or limitless that seems to miss that insight that you're demonstrating in the actual analysis of the materials, about how it is in fact governed by genre and constraint and intermodality. So that's maybe for future.
Right, I will think about it. Thanks.
Frederic?
So yeah, thanks again for the talk, and reacting to the discussion with Nicolas. So we've seen that some notebooks, they can be meant to be read, and that's something that I've seen as well. For instance, so it was like among students, but it can also be professor having a notebook and passing it to the assistant professors, so they can know what he has been doing in his lecture and this kind of thing. And also sometimes then they do not have any link to what is published. Because, for instance, if it's a professor like writing about its lecture and passing it to assistants. So is there an issue about maybe classifying different types of this kind of writings? The ones that do not mean to be read, the others that actually play a kind of role because they address to, I don't know, other students, other professors. Or...
You mean, is this a problem?
No, I mean, is there an issue? Because, I mean, all of them are going to be designed as notebooks.
Yeah. Sure. Well, I mean, the notebook as a material object in the question of draft does not necessarily plays an important role. So for me, it was not that it is a notebook, but that it is a draft of something. But yes, of course, the notebook should be, there should be a sort of typology of the
hierarchy or something.
Something like that. And of course, there are lots, with the Polytechnic lecture notes and all these things that circulate, and we have a lot of examples. Even in Carton's archive, there are notebooks that are not even written by Carton for his lessons. Of course, there is a sort of classification that should be made. Yes. Yeah, of course.
Last question from Meg. Maybe
kind of in complement to this, why have you chosen lab as your concept, and how, what do you think the key features of this notebook that make it a lab is, and how does that relate to the other types of notebooks? And what does this understanding of a lab bring back to other kind of theorizing that's been done at labs before?
So I chose that because I think it's you can think of it as a sort of a place where the mathematician can do sort of experiment with this. Only they are written experiments. And when I first started, I was really inspired by the book on laboratory notebook by edited by, I think, Heinberger and two other people whose name I unfortunately forgot. And I thought it was a good way to try and enter into the question of draft, looking at it like the place where the mathematicians work. And I like the idea that it's a lab because I want history of mathematics to be part of history of science. And so, yeah.
Okay, well, we're in negative time, so let's thank Emmylou very much again.